Hello. What do you think of when you hear the word problem solving? Maybe a fun challenge? Maybe something intimidating or difficult? One thing we would probably all agree on is that it's important and we want to get better at it. Whether it's our daily life or our job, we're going to face lots of problems that we need to solve. And so that's why there's been a lot of books written about this topic over the years. Some are famous, like George Polya's How to Solve It. Martin Gartner also has lots of books about this. A more recent one is Ed Berger's Making Up Your Own Mind, that focuses on puzzle solving. And that's kind of the thing these books have in common, is that they're abstract questions or they're puzzles, brain teasers, which are fun to play with and important ways of building that skill. But for our purposes, we want to focus on real world problem solving. But the techniques that we'll learn in general problem solving will be useful when we're tackling real world problems. And so for this video, we want to focus on the attitudes and strategies that are common in these sorts of situations. So let's talk about attitudes first. I think there's at least 5 attitudes that are useful to develop if you want to be a better problem solver. The first one is confidence. Confidence is the belief that you'll succeed even though the path is unclear. If you're not confident, you might not even start the process. And that's definitely not going to lead to success. The next one is creativity. This is the willingness to try a new idea without any assurance it will work. Certainly some people might think they're more creative than others or less creative, but that doesn't mean that we can't try a new idea. And the more practice we get looking at problems and solving problems, the better we will get at coming up with new ideas. The third one is curiosity. This is the desire to understand the nature of a quantitative relationship. The more curious you are about why something works, the more likely you're going to want to understand the answer. The fourth one is motivation. This is the desire to start a task regardless of its difficulty. If you're not motivated to get started, then it's going to be hard to get started. Now, sometimes you are really curious about something and that helps your motivation, or maybe you've been hired to do it, so you have motivation that way. But if you don't have much motivation, it's going to be hard to carry through. Which brings us to our last one, perseverance. And this is the desire to not give up, even if it gets difficult, even if it means you have to start over. And so notice there's a lot of overlap between these, but the idea is that we have to be willing and interested to push through, because a problem solving by its very nature is not going to be easy. And one more thing I'll say is that if you don't feel like you're good in all these categories, which is natural, then try to solve problems that will help build your confidence or build your curiosity. And the more success you have, the more likely you'll have confidence and motivation and so forth to get better. So practice does help on this. But that's not enough. We need to be able to have some concrete strategies of how to get started. And there's lots of strategies out there, and that's what those books that are out there talk about. So we're just going to mention the key ones, and if you're curious to learn more, you can investigate more deeply. One important idea is to solve a simpler problem. Certainly, it's hard to solve a problem that's complex, especially a real-world complex problem. So the more we can start with a simple one and then build up from there is useful. One way to do that actually is to split the problem up. So split the problem into parts or cases. Another useful strategy is to work backwards. Or sometimes you can work forwards for a while and work backwards and meet in the middle. Either way, that can get you started in a way that you might not have been able to do before. One strategy that we'll be using a lot in math modeling is translating the mathematical language. This will be part of that build the model phase that we'll do more with. Certainly drawing a picture or a diagram is helpful. Another common thing we'll do in math modeling is to look for a pattern or a trend. And we'll learn various tools to help us get better at that. In the define the problem stage, sometimes we'll want to state the problem in a different way. It's interesting how rephrasing the problem can give us a new idea that will be a better approach than what we might have come up with before. A more concrete idea is to just find a similar solved problem. So maybe someone's already tackled something similar to what you've already done, and you can just mimic what their solution is. Nothing wrong with that. On the flip side, sometimes you just have to make a guess or try something. Sometimes we really have no idea how to get started, and we just have to try something and see what happens. Another approach that we'll use a lot in this course is to use technology. We might not be able to do something by hand, but maybe with a spreadsheet or a computer algebra system, we can be more effective. Along those lines, simulation can be a helpful tool. Right? We may not be able to solve for like a mathematical answer or formula, but simulation will give us a solution that's good enough. And then some general ideas that kind of go without saying, but are worth marking down for completeness, is to ask for more information. Right? If you need to know something, if you have a client who came to you with a question, then talk to them. And of course, research what's already known. If you can find something useful without having to rediscover it, that's even better. So these are some of the main ideas. There's more out there, but this will get you started in a lot of the problems that we'll see in the course. And we will focus on a specific example and see these in action in the next video. So we'll see you there.